Hello children. So again meeting with another question. I think this is the second question for the grade 11 2020 club of master maths, and this was about a geometric progression question, another lesson from grade 11. I will try to do more and more videos children, because for the last video there were lots of good responses and lots of children said it was very useful. So when you all get the benefit from this, even I like to put some more time from my busy schedule into this and do a lot of more work with you all. So let's start with this question. As you can see, it says in a geometric progression, the third term is 8 and the sixth term is minus 64. Find the following: first term and the common ratio. In a progression question, if they have given two terms, that means it's an indication, it's a sign that we have to do this using simultaneous equations. Let's see what are the two informations they have given. They have said the third term is 8. That means in this progression T3 is equal to 8. And they have also said the sixth term is minus 64. T6 is equal to minus 64. And in a geometric progression, the nth term can be found by this formula. By now you should have by hearted these things. But anyhow, if you have not, still you are not late to start. So in this formula, the third term will be equal to a into r into n a into r to the power n minus 1. So let's apply that here. The third term equals to a, which we don't know, so we'll keep it as a, r, which we don't know, we'll keep it as r, n minus 1, because it is the third term, n value will be actually 3 minus 1. So that would give you third term equals to ar to the power 2. Similarly, applying the same formula here, the sixth term equals to ar to the power 6 minus 1, and that would be sixth term is equal to ar to the power 5. But they have already mentioned the third term is 8, therefore I can, from this one, I can create an equation saying ar to the power 2 is equal to 8, and the sixth term is mentioned as minus 64. That means ar to the power 5 is equal to minus 64. Now what we have got is two equations. This is equation number 1 and this is equation number 2. Usually in simultaneous equations, we add the two equations or else we subtract. But I have told you all in the theory class, both in online and physical, that if you have two equations in geometric progression, you are supposed to divide them. Always you have to divide. So in here, to make my work easier, I will divide the second equation by the first equation. You can do the other way around also. So that would be equal to ar to the power 5 equals to minus 64. This is going to get divided by ar to the power 2 over 8. And as you can see here, a will get cancelled off. R to the power 5 over r to the power 2. Now r to the power 5 means there are 5 r's, and r to the power 2 means there are 2 r's. So 2 of them will cancel off with 2 of them, which would leave with r to the power 3. You don't have to show this, that was the explanation. And in other words, when you are dividing, the powers get subtracted, 5 minus 2 becomes 3, whatever you are comfortable with. Minus divided by plus is minus 64. When you divide it by 8, that would be 8. So r to the power 3 is 8. Now to find r, try to write this minus 8 also as a number with power 3. Now you all know minus 2 into minus 2 into minus 2 is 2 into 2 4, 4 into 2 8. So that is minus 2 to the power 3. So because the powers are equal, here also you can see the power is 3, here also you can see the power is 3. Therefore we can directly say r is equal to 2. So we have found r. Then we are supposed to find a, and let's do that over here. Since we have found r as 2, I will use it in the first equation here. A r to the power 2 equals to 8. So we know r is 2, so that means 2 to the power 2 equals to 8, multiplication. And a equals to 2 to the power 2 is 4, multiplied by 4, when you take it to the other side, becomes divided by 4. And a finally becomes equals to 2. So that means r is also 2, a is also 2. By the way, I forgot something. R is not 2, I forgot the minus sign, it should be minus 2 here. So r is minus 2 and a is equal to 2. That is the answer. And once I have got that, I can move on to the next part of the question, where they have actually asked you to find out the number of sum of first 9 terms. To find the sum of terms, we have two formulae which we use, but out of them, actually knowing at least this is important. Sn equals to a r to the power n minus 1 r minus 1. So we will use that. So it will be sum of 9 terms. A is, as we found out, it is 2. R, as we found out, it is minus 2. And since it is 9 terms, n is 9. And minus 2 minus 1. So that gives you 2 times minus 2 to the power 9 would be 2, 4, 8, 16, 32, 64, 128, 256. 2, 4, 8, 16, 32, 64, 128, 256, 512. So this is minus 512 minus 1. And why I put a minus sign is, if the power is odd, the answer will be negative. If the power is even, the answer will be positive. And minus 2 minus 1 would be minus 3. So that gives you 2 times minus 513 over minus 3, and 2 times minus divided by minus is plus, so it's a positive number, and this would be 2, it would be 1, 7, 1. That gives you 342. So that is the sum of the first 9 terms of this progression. They have also asked you the number of terms which should be added from the beginning to get the sum of 22. Let me do it in the other side. So we know the progression. The progression is actually having a first term of 2 and a common ratio of minus 2. Again, we use the same formula, Sn equals to a r to the power n minus 1 r minus 1. So in here, a is equal to 2, r is equal to minus 2 to the power n minus 1, and r is equal to minus 2 again. And this side they have given the sum. The sum must be equal to actually 22. So we are supposed to find the n value here. You might remember in the paper class last week we actually discussed a very difficult question of this from the Vishaka College paper. This is an easier version of that, but this is much more likely to come in your O-level paper than that particular question, because that was way too hard. But this is not a very easy one, but at the same time this type of a question can come for O-levels because it's not way too hard. So 22 equals to 2 and minus 2 to the power n, still we can't do anything here, minus 1. On the bottom we have minus 3. Take the minus 3 to the other side, it becomes 22 multiplied by minus 3. Take this multiplied by 2 to this side, it becomes divided by 2, leaving you with minus 2 to the power n minus 1. So in here you can cancel off this 11. 11 times minus 3 is going to be minus 33. Take this minus 1 also to the other side, it becomes plus 1. In here you have minus 2 to the power n. So this becomes minus 32 equals to minus 2 to the power n. And then if you take minus 32, that is minus 2 to the power 5. This side also minus 2 to the power n is there. Why I wrote it as minus 2 to the power 5 is, then the bases are equal, and just like you studied in grade 11 first term lesson, if the bases are equal, that means the powers also must be equal. That means this 5 and this n must be equal. So you can tell n is equal to 5. This is how you do this question. It's a good question from geometric progression. Hope you all understood that. And if you can't recall the formula or these methods, please revise the geometric progression method. And also children, some more exciting stuff are on the way through the Maths Club group and also the Master Maths classes. So please wait for them. And also reminding you, you have about another 138 days for your O-level. So hope you all are studying. Best of luck for all your exams and studies. See you with another video.